All right, so we are going to talk about area of polygons today, and we are going to focus on it as composite figures. There is a different route to go, but we feel like this is the best way to introduce this. So the first thing we need to talk about is what a polygon is. It's a closed plane figure formed by three or more segments. If you try to draw a closed figure with only two segments, it's impossible. So that's why it starts with three. The next thing to talk about are regular polygons, and regular polygons just means that they are equilateral and equiangular. So below there's a figure talking about the most common. They have specific names all the way up to 12. So the first one's a triangle, then square, pentagon, hexagon, heptagon, octagon. So those are the ones that we're going to focus on the most right now. But 9 is a nonagon, 10 is a decagon, 11 is a hendecagon, and then 12 is a dodecagon. But those aren't as important. Now we're going to talk about parts of a regular polygon. So remember, regular means that they are all equal, all sides are equal. So there's a little bit of vocab here. First off, you have your center, right? So obviously that's the center of the polygon. And it's the center of the polygon because we could draw a circle on the outside and it would be the center of the circle as well. So obviously, if you have a circle, you have a radius. So if you draw a segment from the center to any of the vertexes or vertices of the polygon, then that would be a radius. And then we have something called the apothem. Kind of a funny word. It sounds like I'm saying opossum with a lisp, but an apothem is actually the same thing as a height of the triangle that you have drawn. So if you notice, that is the height of that triangle, and it is the same thing every single time. Okay. The apothem actually is pretty cool because it cuts the bigger triangle in half. Okay, and it also cuts these angles in half. So if you are looking at these, instead of coming up with a whole new formula for whatever polygon this is, so if we check it, it's 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. Instead of coming up with a new formula for a hexagon, what we just look at is the fact that we have one triangle made up here, and then we can keep drawing these other triangles, and we would end up having to find the area of this one triangle and then multiplying it by however many other triangles we have, which would end up being 6. So hexagon being 6, we have 6 triangles. All right, so let's get into one of the examples. Okay, so what we're going to do is essentially find the apothem and the radius. Big thing is we're just going to find the area of the hexagon. Okay, so area of the hexagon is what we're really looking for. Okay, so like we said, we have this triangle here, right? And in reality, we have 6 triangles, right? So what we want to focus on is looking at the triangle in general, and we want to come up with the area of one of the triangles, and then we're going to end up multiplying it by 6 because there are 6 triangles here. Okay, so number of triangles is equal to the number of sides, which would be 6. Okay, so in the long run, we're going to end up multiplying by 6. Okay, now on this one, it's a little tricky because we actually do have to use special right triangles here. Now, if you think about it, we talked about there being a circle, and we know a circle equals 360 degrees, right? But now we need it broken up into 6 parts. So each of those angles would then be 60 degrees. So I'm going to draw this triangle out right here. This being the 12, we kind of just rotated it. We have this 90-degree angle, and I know that this whole angle here is 60. Okay, that means if we have the apothem drawn, that this is 30, this is 30, this is 6, and this is 6. Okay, the reason why those are 6 is because that 12 is broken in half. At this point, we need to use our special right triangles, aka our 30, 60, 90 special right triangles here. Across from the 30 would be your n, and what we are looking for is your apothem, which would be across from your 60-degree angle, which would be n root 3. That means that your apothem, which is the same thing as your height, would be 6 root 3, because if it's n root 3 and is 6, it would be 6 root 3. Okay, so at this point, we do have our base and our height of a triangle. Remember, area of a triangle is 1/2 base times height, right? So we have 1/2. My base, which is the whole base of this equilateral triangle, is 12. And the height is the same thing as the apothem, and that's what we just found out to be 6. So we have 1/2 times 12 times 6, which ends up getting 36 root 3. Now this is the area of the triangle. Now we need to focus on the fact that this is a hexagon, which means we have 6 triangles. So area of the hexagon is going to be 6 times 36 root 3, which is 216 root 3. Now we are talking area, so we're going to say units squared. Now, not all of these problems are going to be this complex. I think this is like the hardest version of what you'd be able to see. So you might need to use 30, 60, 90 triangles. You might need to use 45, 45, 90 triangles. So make sure that you have a reference of those special right triangles. And I could probably write that down on one of our sheets that you have today. All right. So we're trying to find the area of a triangle with sides of 16 centimeters. Okay, so we have 16 here, 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 right? Now, same deal as what we were doing before, right? They want us to possibly do the apothem route, okay? But most of you would probably think, okay, it's a triangle, so we're trying to do 1/2 base times height, right? So essentially what we have is a Pythagorean theorem problem, right? If we drop down this height, we know that this would be 8. So now we can use Pythagorean theorem. Now what I'm going to do is I'm going to make these easier. Divide it by 8. So this is 8 times 2. And this is 8 times 1, which remember we can forget about the 8s. If we do Pythagorean theorem, remember it's c squared equals a squared plus b squared. C being 2, so that would be 4. And then 1 plus x squared, that being x. So we have 3 equals x squared, or x equals the square root of 3. But remember, we got to tack on the 8, right? So that is our height of our triangle. So we have area of the triangle is 1/2 base times height. So we have the base, which again is the whole base, which is 16, and then our height, which is 8 root 3. If we multiply all of these, we end up getting 64 root 3. And again, we should have units squared. You can write out the whole word, or you could just put u. All right, next one. We want to find the exact area of a regular hexagon with the sides of length 12. So I'm going to put 12 here. Now again, we have these triangles, right? That's what we're trying to focus on, is finding these triangles. So I'm going to drop down my apothem here. All right, so again, we need to find the area of that one triangle to start, right? So in order to do that, we need to find the height. All right, so again, we're going to look at this as all of these angles on the inside give us 360. Right? And again, this is a hexagon, so this would be 360 divided by 6. Not always going to be the case, but that's what it is right now. Again, so we have this triangle. If every single one of these are 60 on the inside here, then that means that both of these would be 30. And again, we would split this into 6 and 6. Okay, so this is actually the exact same problem as this one. Okay, so going through that, we would go through the same process as this one. Okay, and that's because I went like through everything here instead of just finding the apothem and the radius. All right, let's take a look at this one. Okay, this should seem a little easier because they give you all of the problems. Okay, so they want to find the area of the regular octagon. Okay, if it's an octagon, that means 8 sides, which means that there are 8 triangles. Now you can draw out all of these 8 triangles, which I will do right now, but you don't have to in the future. They just go from the center to each vertex. And if you count it up, you would have 8. Okay. So now again, we're going to focus on this triangle here. They actually give you the height and the base. So area of the triangle, again, is 1/2 base times height. We have our base of 4. We have our height, which is the same thing as the apothem, as 3. So 1/2 of 4 times 3 would give me 6 units squared. Now, that's the area of one triangle. If I want the area of the octagon, then I would need to multiply that by 8. So we have 6 times 8, which is 48 units squared. Okay, so this is what some of your problems are going to look like, but occasionally you do get these types of problems where you have the extra work to have to find the central angle and then use a special right triangle and all of that. Okay, so keep that in mind. Also with this one, you could have went a different route if you wanted to. You could have had this drop down this way, and then you still would have done the same thing. You would have had to find um, some extra stuff there. I think that that's extra work, but you could have looked at it that way, and you still have your 3 triangles, which is similar to what we were doing before. Okay, but I think that's kind of silly when it's triangles. Okay. All right, so I am going to post a worksheet. You can do the same thing that we did with the challenge problems. Please be sure to find a way to show me some work. Even if you just write it on a separate sheet of paper, make sure that it is kind of organized nicely, and then show some work, because this is not something that you can just kind of type in and go with. Because some of us during the challenge problems kind of just gave me their answers, and I can't really see what's going on with those then. If you haven't turned in your challenge problems, make sure you do so ASAP. Okay. Good luck. Please email me or reach out to me if you have any questions, and I will talk to you later. Bye.